Namaste, and welcome back to JEE Physics with Typical Monk. This is class 14, Waves and Sound. A wave carries energy without carrying matter, a shape that travels while the medium itself only shakes in place. Send two such waves against each other and they lock into a standing pattern, with points that never move and points that swing the hardest. Today, we read the traveling wave, tune a pipe, count beats, and hear a passing siren change its pitch through the Doppler effect, one idea at a time. Here is what you will learn today. First, the traveling wave, y equals the sine of bracket kx minus omega t, and its speed on a string and in a gas. Second, superposition, interference, and standing waves. Third, pipes, open versus closed, and the harmonics and overtones. Fourth, beats, the throb of two nearby frequencies. And fifth, the Doppler effect for a moving source and a moving observer, one idea at a time. 4 ideas. Run this entire chapter. Look at them together first. The traveling wave, y equals the sine of bracket kx minus omega t, and its speed, v equals omega over k, which also equals f lambda. The wave speed, on a string, v equals the square root of t over mu. In a gas, v equals the square root of gamma p over rho. The standing wave, two opposite waves superpose and lock into fixed nodes and antinodes, points that stay put. And the Doppler effect, relative motion between source and observer shifts the observed frequency. Now look at the picture. Standing waves in air columns, an open pipe against a closed pipe. First, a standing wave. A traveling wave and its reflection superpose. The nodes stay perfectly still. The antinodes swing hardest, and all of them are fixed in place. The open pipe, open at both ends. There is an antinode at each end. The fundamental fits half a wavelength, so its frequency f1 equals v over 2L. The closed pipe, closed at one end. There is a node at the closed end and an antinode at the open end. The fundamental fits a quarter wavelength, so f1 equals v over 4L. And the harmonic rule. An open pipe gives all the harmonics, 1, 2, 3, and so on. A closed pipe gives only the odd harmonics, 1, 3, 5. Now, the working formulas. The ribbon holds the anchors. The traveling wave, its speed, and the speed on a string. The traveling wave, y equals the sine of bracket kx minus omega t. The wave number k equals 2 pi over lambda, and the angular frequency omega equals 2 pi f. The speed on a string, v equals the square root of t over mu. T the tension, mu the mass per unit length. A tighter or a lighter string carries a faster wave. The speed of sound in a gas. Laplace's formula, v equals the square root of gamma p over rho, and it rises with temperature, as v is proportional to the square root of t. And the standing wave, y equals 2a sine kx cosine omega t. The shape stays put, only the amplitude breathes. Neighboring nodes are half a wavelength apart. Let us work the G favorite, a Doppler shift. A source of 500 Hz moves toward you at 30 meters per second. The speed of sound is 330 meters per second. The setup. The source frequency is 500 Hz. Moving toward a still observer at v source equals 30 meters per second. The sound speed v is 330. The formula. For an approaching source, f dash equals f times v over bracket v minus v source. The denominator shrinks, so the pitch rises. Substitute f dash equals 500 times 330 over bracket 330 minus 30, which is 500 times 330 over 300, equal to 550 Hz. Now, the observer moves too. You move in at v observer equals 30, f dash equals f times bracket v plus v observer over bracket v minus v source, 500 times 360 over 300, which is 600 Hz. So the answer, a still observer hears 550 Hz, with both approaching 600 Hz. coming closer always raises the pitch. Now the picture behind it. Wire passing siren drops in pitch. A moving source. As it advances, each new wavefront is emitted from a point a little closer to the observer than the one before it. Ahead of the source, the wavefronts bunch up, the wavelength shrinks, and the observer in front hears a higher pitch. Behind the source, the wavefronts spread out, the wavelength grows, and a listener behind hears a lower pitch. And the formula ties it together. F dash equals F times bracket V plus or minus V observer over bracket V minus or plus V source. The top signs are for approach, and both motions count. Now what JEE actually asks. 5 pointers. 1. The traveling wave, y equals the sine of bracket kx minus omega t, v equals omega over k, which is f lambda, and on a string, v equals the square root of t over mu. 2. Sound in a gas, v equals the square root of gamma p over rho, rising with temperature as the square root of t, and independent of pressure at a fixed temperature. 3. An open pipe gives all harmonics, Fn equals Nb over 2L. A closed pipe gives only the odd harmonics, Fn equals bracket 2n minus 1 times VOV over L. 4. Beats. The number of beats per second equals the difference, the size of F1 minus F2. And 5. Doppler. F dash equals F times bracket V plus or minus V observer over bracket V minus or plus V source. Approach raises the pitch, moving away lowers it. Now an assertion and reason drill. For each pair are both true, and does the reason explain the assertion? First pair. Assertion: a closed organ pipe produces only the odd harmonics. Reason: a closed pipe has a node at the closed end and an antinode at the open end. Both are true, and the reason directly explains the assertion that boundary pattern permits only the odd harmonics. The answer is A. Second pair. Assertion: the speed of sound in air increases with pressure at constant temperature. Reason: the speed of sound in a gas is the square root of gamma p over rho. The reason is true, but the assertion is false. At constant temperature, p over rho stays constant, so the speed does not change. The answer is D. Third pair. Assertion: two sound waves of nearly equal frequency produce beats. Reason: sound is a longitudinal wave. Both are true, but beats come from the superposition of two close frequencies, not from sound being longitudinal, so the reason does not explain the assertion. The answer is B. Now match each quantity to its formula. The wave speed on a string goes to the square root of t over mu. The speed of sound in a gas goes to the square root of gamma p over rho. The beat frequency goes to the size of F1 minus F2. And the closed pipe fundamental goes to B over 4L. 4 pairs, each worth committing to memory. Now, how many of these 3 statements are correct? 1. A closed pipe produces only the odd harmonics. That is correct. 2. The speed of sound in a gas increases with pressure at constant temperature. That is wrong. At constant temperature, it is independent of pressure. 3. The beat frequency equals the difference between the two frequencies. That is correct. So the answer, 2 are correct. Statements 1 and 3. The trap is statement 2. At constant temperature, sound speed does not depend on pressure. Now the 2 mistakes that quietly cost marks. The myth: an open pipe gives only the odd harmonics. The truth: an open pipe gives all the harmonics. It is the closed pipe that gives only the odd ones. The second myth: in the Doppler formula, only the source's motion matters. The truth: both count. F dash equals F times bracket V plus or minus V observer over bracket V minus or plus V source. The observer's motion sits in the numerator. The source is in the denominator. Now, test yourself. Answer in your head before the reveal. That is how JEE speed is built. Here we go. Question 1. The beat frequency of 256 Hz and 260 Hz. 4 Hz. The difference. Question 2. Which pipe gives only the odd harmonics? The closed pipe. Question 3. For V equals the square root of T over mu, if you quadruple T, the factor on V. 2 times the square root of 4. Question 4. An approaching source. Does the pitch go up or down? Up. And question 5. The fundamental of a closed pipe of length. B over 4L. Let us gather it all in one breath. The traveling wave, y equals the sine of bracket kx minus omega t, v equals omega over k, which is f lambda. The speeds on a string, the square root of t over mu, in a gas, the square root of gamma p over rho, rising with the square root of t. The pipes. An open pipe gives all harmonics, b over 2l. A closed pipe gives odd only, b over 4l. Beats, the size of f1 minus f2 throbs per second. The Doppler effect, f dash equals f times bracket v plus or minus b observer over bracket b minus or plus b source. Approach raises the pitch. Next class, electrostatics, Coulomb's law, the electric field, and Gauss's law. A wave moves energy while the medium stays home, and from that one idea come standing waves in a pipe, the throb of beats, and the rising pitch of an approaching siren. Sarah, David, Lisa, and John all begin exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.